Calculate the molecular weight for each of the following compounds. So I usually start off by writing out a molecular formula before I calculate molecular weight. It just makes the molecular weight easier to calculate. So in this problem, I have a single carbon. Now that carbon needs 4 bonds, but only 2 of them are showing. So I still have 2 hydrogens that I need to add to it. And even though it's double bonded, it still counts as a single oxygen. So going to the periodic table, carbon weighs 12, hydrogen, each one, weighs 1, and oxygen weighs 16. So I have 1 times 12 plus 2 times 1 plus 1 times 16 to give me a molecular weight of 30 grams per mole. In the next compound, I simply have 1 carbon again, but in this case, that carbon has just 1 bond showing to it, so it's going to need 3 hydrogens. But I also don't want to forget the hydrogen that's listed. So this is 4 hydrogens total and 1 sulfur. Going to the periodic table, carbon weighs 12, hydrogen weighs 1, and sulfur weighs 32. So I have 1 times 12 plus 4 times 1 plus 1 times 32 to give me a molecular weight of 48 grams per mole. In the next compound, I have 1, 2, 3, 4 carbons. On the first carbon, I have 1 bond showing, so I need 3 hydrogens. The next one, I need 2. Oxygen's happy with 2 bonds, and 2 bonds are showing, so it needs no additional hydrogens. The same for this one up here. Carbon needs 4 bonds, and 1, 2, 3, 4 are showing. But the last one needs a few more hydrogens. So if I add these together, I have 8 hydrogens altogether and 2 oxygens. Using numbers that we've had before, we have 4 times 12 plus 8 times 1 plus 2 times 16 to give us a molecular weight of 88 grams per mole. And lastly, we have 2 carbons. On this first carbon, we only have 1 bond showing, so we need 3 more hydrogens. But our total hydrogens would be 4, counting the H of the OH, and we have 2 oxygens. So 2 times 12 plus 4 times 1 plus 2 times 16 gives me a molecular weight of 60 grams per mole.